Okay, you have 10 minutes. Please begin now. Okay, so that's time. So let's have a look at these graphs. So these are classic graphs that you can get on the exam. And so this, I don't even know what it might be called. This might be called physics because it's audiograms. It might be called biology because it's audiograms. And so either way, this type of graph is quite classic. Of course, when you see a graph, you check any titles it might have, you carefully read any caption which might be there. In this case, um, there is a caption, there is content. Sometimes Acer will have a caption for the graph, but sometimes they don't. They'll just have figure 1 or figure 2 or something like that. And of course, you assess the X and Y axes. You know what is being measured here, and you look at um, the intervals to make sure that they're regular. So we see that these are regular intervals. So we're going to imagine that if you have only regular intervals, you're thinking more in terms of linear relationships. Now, of course, if you have done your physics studies, you also know that, yeah, this is linear in terms of the units given here, which is decibels, but decibels are on a logarithmic scale. So that's a complication that could sometimes come up, but there's no such complication in this case. And then we have the frequency in hertz, and you can see that the intervals appear to be regular, but definitely not linear, because the difference between each one of these intervals is always 20. The intervals always remain the same. But then here, the intervals are always changing. The interval between these two, 4 and 8, is just the number 4. Between 8 and 16, it's double that. It's 8. And then between 16 and 32, it's 16. So this is exponential. So some people might say the scale is exponential, but often it's said to be logarithmic because they are both related to each other. So when you see this, when you see that the intervals are changing, then hopefully with time, you have an alarm in your brain, realizing that this means that Acer might be asking questions based on your understanding or acknowledgement that these things are changing. Okay, and we're also told in the caption comparison of the present pigeon audiogram with the pigeon audiogram of, let's say, K and Q, which differ in only lower frequencies with the human audiogram. So we clearly see the human audiogram. We see the present study, which is here, going like this. And notice that this other graph for K and Q, it's the same sort of image where you have a black dot and then some dashes and a black dot. So it's the same as this. So this graph continues here and continues here. I can see this visually because they use the same symbols on the graph, but it's also stated here because it says that the two different pigeon graphs, the present study and the K and Q graph, differ only in the lower frequencies. So this is frequency, and these are the lower frequencies, lower numbers. So here they differ, but in the higher frequencies, they do not differ. So that means they share this same pattern in the higher frequencies. Okay, so then let's look at question one. Number one, hearing range describes the range of frequencies from lowest to highest that can be heard by humans or other animals. According to the diagram, which of the following has the greatest hearing range? We want to know which one has the greatest range from highest to lowest number. So hopefully you assess this, and then you check each one. So we look at A, and we look pigeons from the K and Q study. So I'm just going to write that here. And so I'll write K and Q. And so we look at where it starts. So K and Q starts somewhere around here. which is, I don't know, somewhere around 0, 0.05, or it's less than 1. Okay, so it starts at a number that's less than 1, and then it goes up to here. And if that lines up to about 8,000, because it says 8K, and K is for kilo. So it goes from around less than 1 to 8,000. And then this answer choice B is pigeons from the present study. And present study starts somewhere around the number 3. Okay, it doesn't matter if you're off by a little, it would make absolutely no difference. And that's also going up to 8,000 because it shares this. And then we check humans, which is answer choice C. And human, let's say it starts at around 4. Okay, it doesn't matter if you said 6 or 8 or 2, it just wouldn't even matter. You're going to develop that skill of approximating during the real exam. And then we follow the human graph, and it goes up to, wait, that's looking like 18K. And so we see that the answer must be C, humans. And in fact, let's take a step back for a moment, because when you're hearing the greatest range, you don't let your eyes fool you. Don't believe your lying eyes, because when you think of range, you're thinking about which graph is widest, and the K and Q one would be widest. But when this is an exponential scale and it's only going up to 8,000, but these other graphs look quite similar, but they're not similar at all in terms of their range, because this one, just by having this little gap, is the difference of 10,000 units, which is a massive difference. In fact, I'll give you a little expression that you should consider memorizing for GAMSAT purposes. And that is, small differences at the upper part of an exponential scale are far more important than large differences at the lower part of the scale. So this is something to keep in mind. So that's what looks like a small difference is a massive difference as we can apply the scale. Okay, so the second question, the present study as opposed to the K and Q study, suggests that the established hearing range of pigeon should be increased by 20%, decreased by that, approximately 50%, or changed by approximately 0%. So then let's look at the difference. Let's look at the difference between these two. And the difference between the K and Q and the present study is approximately 2 units out of 8,000. So when you look at the graph, it looks like the difference is significant. But when you count the actual numbers, this big difference at the lower scale of an exponential curve is of very low significance. 2 out of 8,000, which is approximately 0.03%, something like that, which is almost 0%. So it's a very small difference. And so the answer for 2 is D. And then we have question number 3. According to the diagram, how many of the 3 graphs suggest the ability to hear 20 decibels and 125 hertz? So 20 decibels and 125 hertz. Okay. So I look at 125 hertz here, and I'm going up, and I'm looking at 20 decibels here. And by doing so, I can see that there is only one graph below this, and it's human. Human is the only graph, because we're talking about a sound which is above the threshold for human. So you didn't have to study anything about hearing, nothing about physics to get these three questions correct. You hear that there's a threshold. That means it's a minimum value for hearing. So you have to have something above the minimum value in order for you to hear it. So humans can hear this sound above the minimum value, but neither of the pigeon studies would be able to hear this sound because it's below the threshold for them to hear. Okay, now let's move on to a question that doesn't require any previous knowledge, but it doesn't require any previous knowledge in physics or chemistry, but it does require your ability to use logarithms. So according to the Arrhenius equation, so you're given the equation k equals all of this, where a is the Arrhenius constant, e is the base of natural logarithms. So hopefully you've done that study. If not, you're going through it. Of course, if you have the Master Series book, you can go through it there or watch the videos that we have on the website, or you can try Khan Academy or some other resource to get yourself up to speed for the exam in terms of logarithms. EA is the activation energy, R is the ideal gas constant, and T is the temperature in Kelvin. Which of the following options represents a graph of ln K versus 1 over T? Okay, so what I'll do is I'll start by showing you the work solution. You can take an image of it, and then I will begin to explain it so that I can give you the details on how that works. Let's get that. Okay. Okay, so maybe you can just take a screenshot or something of this, and then I'm going to start to talk about it. Okay, so we have K is equal to all of this, according to the information that we're provided. But when we look at all the graphs, all of the graphs have ln K versus 1 over T, as mentioned in the question itself, that the graph is, all these graphs are structured that way. So our objective, therefore, is to get ln K on one side of the equation and 1 over T somewhere on the other side of the equation, because in the back of your mind, you should be thinking about this. Y is equal to mx plus c. If you have a straight line graph, it follows this. So y will be your y-axis, x the x-axis, m will be the slope, and then c will be the y-intercept. Where does the line intersect the y-axis? So if we can make this thing, the equation that we're provided, look like this, where y will be our ln K, because that's what the graph is, and then x will have to be 1 over T, because that's what we have over here. So that's what we're going to try to do. So first step, we have this equation set out. We know we need ln K on the left-hand side. So then we take ln, which is the natural logarithm. We take ln of both sides. Why? Because just like all basic algebra, if you have an equation, an equal sign, and you multiply one side by 5, you have to multiply the other side by 5. If you divide both sides by 10, you have to divide if you divide one side by 10, you have to divide both sides by 10. Anything you do to one side of the equation, you have to do to both. So if I want to have ln K on the left-hand side, I have to also take the natural logarithm of the right-hand side. And according to the rules of logarithm, if I have two things that are multiplied by each other, I can separate them and add them as logarithms. So I used these rules of logarithm to get to this second line. Now, also using the rules of logarithm, I have the natural log here of e to an exponent. But when you have the natural log of e to any exponent, the answer is just the exponent. So I can remove ln e, bring the exponent down, and I just pushed ln a to the right. Why? Because I know where I'm going. I'm trying to get y is equal to mx plus c. And so what do I learn? I learned that ln k is y. I learned that the intercept for the y-axis is ln a, and the slope and x have to be in here. So I know that x is 1 over t because that's according to the graph. So I'm going to pull out 1 over t, which is my x, and I'm left with negative EA over r. All mathematics. So I'm just pull out the 1 over t, and I'm left with negative EA over r. And so, what have I learned? I learned that the slope of this graph is going to be negative because of that negative sign. So the slope is negative, and you would have learned in primary school, if it has a positive slope, it's moving uphill. If it has a negative slope, it's moving downhill. There's only one graph that has a negative slope. It's A. So the answer must be A. Also, they could have asked me, at what point does this line intersect the y-axis? And I know what this point is. It must be ln A, which is the y-intercept. Okay, so, and so just try to imagine how many students are going to be, trying to get a chemistry textbook and studying from that, hoping that that's going to help them get a great GAMSAT score. But what you need to do is, as you are studying, you're continually doing GAMSAT level practice questions so that you're not left in the dark. Okay, and a couple of relatively easy questions to end it off, especially if you've done any biomed. So we have these classic sigmoidal S-shaped curve for adult hemoglobin, and we have the curve for fetal hemoglobin saturation. Okay. And so we clearly see that one is to the right, one is to the left. But let's see if we can understand what that means. Now, I know some of you might have memorized or know this off the bat, but you're supposed to be able to deduce it. Okay, so we have partial pressure of oxygen. So that's an expression used in chemistry in order to indicate concentration, because usually when you talk about concentration of solutes in solvents or so-called solutions, then you talk about moles per liter. That's the most common to talk about in terms of concentration. But when you talk about gases like oxygen or nitrogen, the concentration is usually measured in terms of partial pressure. So we have the partial pressure in millimeters of mercury along here, and we have the saturation of hemoglobin here. So let's see, what would we say is the difference? Well, let's take a look at an example. If you had a partial pressure of oxygen of 20, and you compared these two graphs, a partial pressure of 20 will produce an adult hemoglobin with 10% saturation. But that same concentration of oxygen will have fetal hemoglobin at, say, 60%. Wow. So for the same concentration of oxygen, fetal hemoglobin has much greater saturation. That means if the two molecules, fetal and adult hemoglobin, were exposed to the same amount of oxygen, one of them has a higher affinity, a higher desire to mop up that oxygen. And that is clearly the fetal hemoglobin. Okay, so that means the, for question number 5, the answer is A. And this is not talking, these graphs have nothing to do with how much oxygen a molecule or a bunch of molecules is having at any given moment. It's talking about the ability, like a sponge, which sponge can sop up the most water. And we're seeing that here, and that's clearly defined as affinity. And the word affinity is just being used in the same way you would use it in the normal English language, no special scientific meaning in this particular case. Okay, and the last question. In an adult human, there are approximately 5 liters of blood, which circulates about once a minute. So this is going to be dimensional analysis. This is you looking at the units, being careful that everything sort of cancels, and then you come up with an answer. And if you've done a few questions in dimensional analysis, which is very important for this exam because it's a tool that is used on almost every GAMSAT multiple times, as well as graph analysis and flow charts. So it's something that you just, you definitely would like to get comfortable doing. And let me just find my calculation. Okay. So first, I'll show it to you, and then we'll talk about it. So you can take an image if you want. Okay, so I have information. 5 liters of blood which circulate about once a minute. Now, we're told that 100 centimeters cubed. Now, a centimeters cubed is the same thing as a milliliter. So centimeter cubed, you can call it cubic centimeter or cc or cm cubed, or you can say milliliter. So we have 100 milliliters of blood in the pulmonary vein carrying this amount of carbon dioxide, and then we have blood in the pulmonary artery carrying obviously more carbon dioxide. So what we're looking at is how much carbon dioxide is lost from the body or excreted. Well, if 55 centimeters or 55 milliliters goes to the lung and 50 returns from the lung, then the difference is 5 milliliters of carbon dioxide in 100 milliliters of blood. That's how much is being excreted. So in the dimensional analysis, I will write that as a fraction. We have 5 centimeters cubed of carbon dioxide over 100 milliliters. So that explains this point form part. And then we can multiply this by 5,000 milliliters, which is the 5 liters of blood which circulates in about once a minute. So we have 5,000 milliliters per minute. Okay, so the milliliters cancel, 2 zeros cancel, and so we have 5 centimeters cubed times 50 is going to equal 250 centimeters cubed of carbon dioxide being excreted per minute. Okay, and we're doing this by following all the units. And it's one of the expressions, if you continue to show up to these, you'll hear me say, and that's that if you understand dimensional analysis, if you practice with it, you will be able to get some questions correct on the real exam without fully understanding the question. And the reason is that you're just following the units. What is associated with these units? If I want to change it from one thing to another, I need to have some sort of variable to change it. Okay, so those are today's questions. As I mentioned, there is the live chat where you'll be able to put any questions that you have. And also, we have a forum, gamsatprep.com/forum, so that during the week later, if you're watching the video and there's something that, oh, no, I still don't understand that, you can always post in the forum. It's always free. And then you'll get an answer within a day or so. Okay, so now for the special presentation. We have Janeth, who has a wonderful story to share, and also will give you some encouragement from the other side, having completed what you are going through today. And of course, we'll have another free tutorial in the next few weeks that'll be posted on our website. And yes, so Janeth, if you are there,
Yes.
please join and tell us your story. And I'll be monitoring any questions posted in the live chat, or at least Petra will, and then I'll give them to you in time.
Thanks, Dr. Ferdinand. I say it's an honor to be here, given that it was just about this time last year when I was attending your free GAMSAT tutorials and whatnot. So just for anyone out there, I'm Janet Fernando. I did the GAMSAT for the very first time last March, in March 2024, and I got a 68 overall score, which was in the top 10 percentile. That was a split of 56 in section 1, 71 in section 2, and 76 in section 3. Together with my GPA, which was relatively on the stronger end, that was enough for me to get an interview offer at the University of Melbourne. And from there, I was successful through my interview as well to get in as a CSP offer in the metropolitan region at the University of Melbourne. So really went through much more ideal than I could have ever imagined. But look, I'm here to want to share my story with you guys. So just provide a little bit of encouragement along the way to say that, yeah, you can really get in on the first time. Probably circling back about a year and a half now to about September, when I first started thinking that I wanted to do the GAMSAT for the first time in March of the following year. It was really about systematically trying to figure out what exactly does it look like. I had friends that had done the GAMSAT multiple of times, but had not been able to get in. So I just wanted to make sure that I didn't fall for some of the same mistakes which they were doing. And I guess just the main thing that I could probably take here from my GAMSAT journey is the importance of really just applying yourself once. If you apply yourself once and you sort of just do the GAMSAT for the sake of like, okay, this is the one time that I'm going to do it. It's sort of, yes, it may put a little bit of extra pressure on you, but I don't think that pressure is a bad thing. Some people can really thrive in pressure. And I think that is sort of what the GAMSAT is all about, really, in terms of thriving under pressure. And so if you can put yourself in a position where you are able to apply yourself throughout the entirety of the, let's say now 2 months to the GAMSAT, you'll see that the rewards naturally come in that way. So a great example of that, I've got a couple of examples with me, is with regards to section 2. So from about this time last year, I'm not sure if you guys can, let me just unblur my background if that's okay. So if you guys can see here, I've got, these are just some of the plans which I was making along the way for section 2. So section 2 is very driven by themes. And so what I have got about 40 or so plans on different themes, and what those themes are. It could be like friendship, could be love, could be space. All of these different themes can interact with each other in one way or another. And if you attend any of Dr. Ferdinand's sort of webinars like this, you'll really see that in terms of section 2, the basal level student writes to the theme. So if the common theme across the 4 quotes you get is love, they're going to write something about love. But how about taking that extra step further, and instead of just writing about love, think about love in the context of social media. Think about love in the context of what love means in terms of, let's say, how it's become as an economy, like terms that in Valentine's Day. If you don't purchase a gift for your loved one on Valentine's Day, is that really love? that sort of image in terms of social media. So in terms of section 2, the biggest thing that I can emphasize from here on in is it's never too early to sort of start writing. And like, trust me, when I wrote my first essays in terms of practicing for the GAMSAT in about December, they were really bad. They were not in time. They were really long. They didn't get to the point, but it was almost that level of confidence needed in that way to just be like, okay, that's the base. That's the base now. And when I look back on 4 months later after the GAMSAT is done in March, it's just like, yeah, that's not what it is now. But doing these plans, brainstorming, I think that's a really good thing. Staying informed. Like, I like a lot of different sources, like The Economist. One of the other things which I really like, I'm just going to bring it up, is these master series books with the GAMS. You can see the annotations and the notes which I've got throughout them. I really like the way that this book has been laid out, and there's across the subjects, there's 6 books altogether, and not in terms of advertising Dr. Ferdinand in any way, but from my heart, I truly mean that these gold standard books were really helpful in the whole journey in terms of section 1, section 2, and section 3. So in terms of section 2 tips, the main ones I can give is write early and write often. Plan early, plan often, and stay informed. That's sort of what you need to do for section 2. And I think the really important thing is not just looking at the theme at its basal level, but also considering it further on in a more deeper level as well. In terms of section 1, I found that this was the hardest for me to improve on. But one of the things that I found really helpful, I'm just going to bring something up which I used very close to. Sorry, just give me a second. I'm not sure if you can see that. Can I just get a thumbs up if anyone can see that? Yeah, awesome.
We can see.
So thank you, Dr. Ferdinand. So this was something which I found really beneficial when doing questions. I'll actually start off with this document first. So yes, this was something that I used a lot during my sort of practice. Whenever I did a question, I logged it into a question log. So you can see my answer, the correct answer, what the major skill type was. So we're looking like, is it a creative text? Like, is it a passage? Is it a non-fiction? Is it a fiction? Is it a technical text? Like that's more so in that non-fiction range. And then is it a visual text? Is it a cartoon? Is it a comment? Or is it something otherwise like that? And then the difficulty level of the question, and then figuring out what the mistake category is. I think this is the really key part, is sometimes we get allured into doing a lot of focusing on what we get right, but I think it's almost better for the GAMSAT to think from the glass half empty perspective and focusing on where your mistakes are. So if you can figure out exactly what mistakes you're making, it really helps you sort of prevent that occurring in the future as well. And sometimes I like to write the key takeaway as well as what the question source is. So you can put the date of the test performed, and you can see I did about 700 questions here, but it's not so much the number of questions, it's about the quality of the analysis and the reflection that's done afterwards as well. And then when I get into an exam situation, I changed tact from going by question basis and more so focusing on what the sources of error are. So for instance, not using process of elimination correctly. Failing to consider nuances between 2 options in a 50-50 is a big issue that a lot of students come across in section 1, as with myself. And I must say, the 56 which I got, I was quite happy with in the end, because it's very hard to improve in section 1. And I think everyone can attest to that that's done the GAMSAT before and continues to do it. So I think just don't sort of become disheartened if you're failing to get the nuances in 50-50s, because a lot of the time it's really hard to decipher between 2 of them. And what you see may not be what ACER sees on the other end, but really just try to be diligent in terms of figuring out what exactly the sources of questions you get wrong. And another thing that may help with that as well is creating stem by stem feedback. So the stems themselves don't link between one another. So you can actually treat each stem as its own mini exam in a way. So from the ACER green text, for instance, the first stem was worth 10 marks. And so I got 4 out of 10. The whole text, the main text itself was a technical text. And then I was able to provide comments myself. So it's mean you can give these for someone else to provide feedback, but I think self-reflection is a really important thing that you can be doing throughout all 3 of the sections. Well, I mean, technically not all 3, because section 1 isn't section 2 isn't connected anymore to section 1 and 3, but you understand my point there. And with section 3, I think just the biggest thing I can emphasize is the importance of problem solving. Now, there's only so much you can do out of understanding a physics, a chemistry, a biology textbook, because the content there, and I'm a strong advocate of this, is that you could go into the exam without knowing a lot of content. This is exactly what Dr. Ferdinand has showed to you in this webinar as well, is a question like this, question 5 and 6. You don't need to understand what fetal hemoglobin is. You don't need to understand what adult hemoglobin is, what the roles of them are. You just need to understand how to read the graph, not fall for the traps that ACES sets for you through logarithms and dimensional analysis, overcome those sort of issues, and then really, if you can get yourself into a 50-50 scenario based off of whether it's the units in the question, whether if 2 of the answers diverge in one direction, 2 of the answers diverge in another, but you know that it can't be going one of those directions, you've already got it down to 50-50, and you haven't even done any of the core part of it. One of the big questions, which I know a lot of people ask, and I was also pondering that throughout the process leading up to my March GAMSAT last year, is whether to read the STEM first or the questions first. And I'm a big advocate of reading the actual STEM first, for the reason that if you read the questions first, you can sometimes become biased into looking for something that may not be there in the text, and that in itself can waste some time. So if you go through the text first, you understand what each chunk of the text means, you break it down into your own words. When you come across the question, you automatically know exactly where to go and look for. I think it's something that you need to work at yourself as well, because I know some people have had success with reading the questions first and then the STEM. But in terms of the GAMSAT, yes, it is a challenging exam, but I really do endeavor to start practicing early, practice often, and I work full time in leading up to my GAMSAT. But I always try to find those extra 2 to 3 hours after coming back from work. And yes, that may have meant longer nights going into 10 p.m., for instance, but it was just so much worth it, because getting in that first time, I wouldn't have been able to do so if it wasn't able to endeavor through that entire process. And if there's anything that I can say is, rather than having to spend $600 on an exam and not doing it to your total capacity, just do it that very first time, because it's going to be so worth it, and you won't regret putting everything in and getting the mark and it not being enough. But what you will regret is not putting it all in, getting the mark that's on the border, and if you got 1 or 2 more marks more, you would have been set for an interview, but you just didn't get there. So I think those are my overall tips, and I'm happy to take any questions which come about in the chat or otherwise.
Yeah, I just want to underline a couple of things that you said, which I definitely agree with. One is that whole issue of giving it your best when you're sitting the exam. And it's just that there's some students, a large number of students, perhaps even a couple of thousand every session, who will say to themselves and to their friends, "Oh, I'm only sitting it as a trial. I just want to see what it's like." And they have this mentality. But the problem with that is that it's almost an excuse not to prepare and study as best as possible for the exam. And what often happens is that the exam ends up being such a traumatic experience when you don't even study, that you don't benefit from the fact that half of the questions will be repeated, because you don't really understand what's being presented to you. So you can't even say, "Oh, I have a starting point. I'm going to start preparing this one." In order to benefit from the exam experience to the maximum ability, even if you're imagining to use it as a trial, which, is not the ideal strategy, but still, if a person imagines to use it as trial, you still do your best, because then you can extract as much as you can from the exam experience. Then you really understand the types of questions, how to manipulate, variables, and how much time was wasted studying if you didn't have a clear path. So I definitely agree with you for that. I have Petra monitoring questions. There was another thing that you had said.
I think Adam's got his hand up as well.
I'm sorry?
I think Adam has his hand up as well, or raised his hand.
Okay, yes. So please, if you can just in the chat, Viv has put the link to gamsatprep.com. Just go to gamsatprep.com, click on the live chat button, and so your question will be transferred. So if you can click on the live chat button on gamsatprep.com, then we'll be able to get Janet to answer your question.
I guess just whilst in the meantime, another thing that I can add in regards to the interview process, and for those that are fortunate enough to get a score that is in that range of, is it enough to get into your dream university? If you get into that sort of higher, above 65 range, so my GPA was 6.94 out of 7, so it was quite good. But obviously with the GAMSAT, it was 68 overall. For University of Melbourne, it comes down to 67, given they weight all the sections the exact same and not the ×2 bonus for section 3. And so there was a time of purgatory for me where it was like, oh, is this going to be enough? Is it not? But it was. And I think getting that interview offer felt like a big relief. I'd never sat, obviously I hadn't sat the MMI before at the University of Melbourne, but knowing that you're good enough to get an interview is a really, really big thing. And so even then, if you put your all in and you get into a position where you can get an interview, that in itself can be fulfilling. And being able to get an interview means that you're competitive enough, not only this year, but you should be competitive enough in subsequent years as well. And so getting the GAMSAT really, now that I'm in medicine, it's a bit surreal. And starting next week, it's going to be a big difference, considering this time last year I was studying for the GAMSAT, but I would like for you guys to also be able to feel this sort of experience as well. And I think the main thing that I would say is throughout the entire process, it's not an easy journey, but you just got to put faith in yourself. Trust that you can do it, because there's a reason why you're here 2 months before the exam, wanting to absorb all this information. And just because you do it now doesn't mean that you shouldn't be doing it in 2 weeks' time, in a month's time. But it's also really important not to burn yourself out. So I know it can be a bit contradictory to say put it all on the line and do as much as you can to put yourself in the best position, but it's also really important not to burn yourself out a couple of days before the exam, because the exam in itself is quite stressful, and it's a tense environment, and you've got to make sure that you're in the best frame of mind to be able to attack all the questions accordingly. So I think just start progressively, get all the foundations down. This doesn't mean you need to go through all the chemistry, biology, physics textbooks out there, but get the groundworks down. Understand what sort of different in biology, how the heart works, those sort of things, because a lot of stuff comes out of the heart in terms of oxygen and the way the blood moves through the heart. But there are certain things that you may not need to understand at the same time. And so really, when you do a lot more questions, you'll understand what are the common questions that ASA puts out there versus the uncommon ones, and that should dictate, almost as if you have learning outcomes, that should dictate how you study, the way you study, but focus on problem solving for section 3 and focus on really trying to pick out those nuances between 2 answer options in section 1. Those are the 2 main tips for those 2 sections.
Absolutely. Problem-based learning. Well, thank you for sharing your journey. I think it's encouraging for students to know that what they're doing now will help in the future. And also, I take your point that that they're here a couple of months before the real exam, and that is a good sign.
Yes,
Well,
for
thanks
sure.
again, and thank you to all of you who attended the webinar, who watch this later in video. And you can leave any questions in also in the for the YouTube video, and we'll make sure that Janet also gets a chance to respond to those. So thank you all for today, and good luck with your studies, including you, Janet. Good luck with your
Good luck.
studies.
Thank you, Dr. Ferdinand. It's a pleasure.
Bye for now.